Welcome to this explainer. Today, we're jumping right into something I find absolutely fascinating, the surprisingly simple secret behind artificial intelligence. You know, we are constantly hearing about these incredible new algorithms and massive neural networks, but we're going to prove that the real magic isn't actually in the complex math or the cutting-edge code. It's actually all in the data. So let's start with a massive question, right? Despite all the hype and the literal billions of dollars pouring into the industry, why do a shocking number of AI initiatives completely miss the mark when they finally hit the real world? It's a total paradox, and it's left countless executives, engineers, and developers just scratching their heads. Just consider the sheer volume of failure we're talking about here. It's staggering. Industry research actually shows that up to 85% of AI project failures are entirely due to data-related issues. And it gets crazier. Separate analysis reveals that 87% of data science projects never even make it to production. The primary culprit? It isn't a lack of computing power or bad coding. It's just inadequate or poor quality data. To really put the scale of this problem into perspective, $3 trillion. That is not a typo. That's the estimated cost that bad data inflicts on the U.S. economy alone every single year. Dealing with these data quality issues manually imposes an immense, almost unimaginable burden on basically every industry trying to innovate right now. Okay, so what's actually going wrong here? To understand these massive trillion-dollar failures, we really have to look closely at something called training data. Now, training data is just the core collection of examples that could be text strings, numbers, images, audio clips that we use to teach machine learning models how to recognize patterns, make predictions, and fundamentally understand our world. Honestly, the absolute best way to visualize this dynamic and make it super easy to wrap your head around is through a classic student-teacher analogy. Think of the AI algorithm as a student and the training data as the textbook. The student adjusts its internal understanding based purely on the empirical evidence it consumes from that textbook. Without the book, the student is functionally inert. They've got nothing to learn from. Just like in a real classroom, even a mathematically brilliant AI student who studies from a flawed, biased, or outdated textbook is inevitably going to fail the final exam. If the foundational information is wrong, the underlying intelligence of the architecture simply doesn't matter. The AI can literally only ever be as smart as the examples it learns from. Which brings us perfectly to a foundational rule in computer science: garbage in, garbage out, or GIGO for short. It's a simple, universal truth. If you feed a system inaccurate, poor quality, or irrelevant inputs, it will inherently generate unreliable, poor quality outputs, no exceptions. So what does this garbage actually look like in the wild? Well, in the world of machine learning, it usually takes a few specific forms. It can be wildly inaccurate information that completely throws off a pattern. It can be missing data points that leave massive gaping holes in the AI's understanding. Or it can be something called label noise, which is really just a fancy way of saying human annotators incorrectly or vaguely labeled the examples the AI is trying to study. But let's flip it and look at a huge success story. KLM Royal Dutch Airlines successfully trained their Bluebot chatbot specifically because they did the hard work on the data side. They fed the system thousands of meticulously labeled real-world customer conversations about flight changes, baggage, refunds, all of it. Because it learned from highly structured, clean inputs, the model understood exactly how to generate accurate, context-aware responses. Customers got their problem solved in seconds, not hours. On the flip side, picture a manufacturing assembly line using computer vision to spot defects. If human experts standing on that line can't agree on whether a mark on a product is a genuine scratch or just a piece of dust, well, how can the AI system be expected to make that call? The AI student literally inherits that human confusion, and you end up with a high rate of false rejections and a failing model. To prevent these incredibly costly failures, data can't just be gathered randomly. It has to be systematically engineered. It actually needs to meet 5 core dimensions of quality. Think of these as the essential building blocks for any stable, reliable AI system. Let's walk through this checklist real quick and see what each means for the health of a model. First up is accuracy. Basically, is your data telling the truth about reality? It has to be completely free of misleading errors, measurement flaws, or that label noise we talked about earlier. Because if the data is telling the AI a lie about the real world, the AI will confidently repeat that lie right back to you. Number 2 is completeness. Your data set must cover the full spectrum of scenarios the AI is actually going to encounter out in the real world. This is absolutely critical. If your data misses rare edge cases or underrepresents certain environments, your AI is going to completely break down when it inevitably hits those situations in the wild. Moving on to third, consistency. This one guarantees that all incoming data follows a standard, uniform format and structure. Think about it. If half your dates are formatted month first and the other half are day first, the AI is going to get totally confused. That severely impairs its ability to efficiently process and analyze the information. Fourth is timeliness. Data has a shelf life, and freshness plays a massive role in AI performance. Feeding an AI outdated data literally trains it for a world that no longer exists. If you're trying to predict stock market trends or customer behavior, old data will just lead to completely irrelevant or even actively misleading predictions. And finally, number 5, relevance. It sounds obvious, but you have to ensure the data actually matches the specific problem you're trying to solve. Feeding a model unnecessary or totally unrelated variables just clutters up the system, making it so much harder for the algorithm to focus on the essential patterns it actually needs to do its job. And that is our 5 critical dimensions. Now, zooming out a bit, recognizing the immense power of those 5 dimensions has sparked a massive, foundational paradigm shift in AI development. We are currently watching the entire industry move away from traditional model-centric AI and rapidly transition toward what is called data-centric AI. See, for literally decades, the standard practice was model-centric. Developers would take a fixed, static dataset, flaws and all, and they would just endlessly tweak the AI's code. They'd change the architecture, wiggle the parameters, basically desperately trying to force the algorithm to somehow compensate for the bad data to get better performance. But the data-centric approach, it totally flips the script. Instead of endlessly fiddling with the code, developers keep the algorithm constant and use systematic engineering practices to continuously clean, structure, and improve the dataset itself. It treats data not as some static, one-time resource, but as a dynamic product that requires rigorous, ongoing engineering. And don't just take my word for it. Legendary AI pioneer Andrew Ng explicitly states that perfecting the code is no longer enough. The algorithms have gotten so good that the real breakthrough now comes from systematically optimizing the data pipeline. That is exactly how we unlock the true value of AI in complex fields like healthcare, finance, and manufacturing. We are literally seeing this exact data-centric philosophy driving the biggest, most exciting successes in the industry right now. It's how OpenAI openly diagnosed and fixed early errors in massive models like GPT-3. It's also exactly how Tesla pulled so far ahead in autonomous driving, they credit their relentless, model-assisted data engine for systematically improving and curating their training datasets on the fly. So, bringing this all together, as neural networks become increasingly sophisticated, we have to realize that the ultimate bottleneck for achieving reliable, trustworthy artificial intelligence isn't about having more computing power or a cleverer algorithm. The ceiling on AI performance is entirely 100% determined by the purity, accuracy, and diversity of the textbook we ask it to read. Which leaves us with a pretty massive, almost uncomfortable thought to end on as these systems integrate deeply into our healthcare, our finance, and our daily lives. If AI is truly only as good as its training data, who is ensuring the quality of the data running our world? It's a question we all need to be asking. Thanks so much for joining me on this explainer, and hey, keep questioning the data.